Okay, so
I'm
it's
ready to do a presentation.
it's recording.
Are you sure it's facing where you used to?
Yeah. Okay, so
Just AC motor and then I should be there.
okay, so going back to this, with any motor, the generator out here is spinning anyway. For water falling, or you have an engine, this is a dynamo. It's spinning, and as it's spinning, right, we know that this is going to go, these are magnets. These were big magnets, and as it was spinning, these magnets were dragging that magnetic field across wires. That was Edison's and anybody else's, right? But they knew that this was going to go, this positive, negative, was going to change this. As this positive was dragging here, this charge was going this way, and as this negative pole came around, the charge would then go back. And they said, well, that's useless, right? Tesla said, well, it already rotates. This is physics for you. This rotation should transfer to something and then transfer back to rotation here. And so you have this current going out, changing directions all the time. Well, that will be applied to this motor. And let it change directions, he said. Let it go this way, that way, this way, that way, constantly. Clockwise, counterclockwise. And as it does that, this here will change. Negative, positive. As fast as it can spin. And as it does that, this also, let's just imagine this winding here at one instant in time. As this generator, we'll just do one instantaneous moment, right? Let's just imagine that this dynamo here is facing like this. This is the negative, this is the positive. And we just simplify it to one. This is an idealized version. This here winding sits here, and it goes to this side of the motor, right? And this one sits here. Well, right now, this is positive. This is all positive. This is negative. This is negative. This, we'll just do the same thing on the motor. This pole wants to go here, right? As it's rotating here, this one wants to go here. That's nice. That's a couple. Now, as this rotates, right? Let's say it rotated one full revolution. Now this is positive, this is negative. As it's going to be, obviously, positive, right? Negative. This is now negative. Where is this going? This already rotated because it was rotating this way. We'll just draw it.
That's what timing is, right? That you have it.
Yeah.
Okay, that you have
That's periodic motion.
Okay.
So as we know that as that rotor was rotating because it was attracted to the opposite pole, it probably swung across it, right? Now this was negative, this was positive, as we remember when you look at the video, right? But this is now it just changed. This now repels. This is pushing it away, but it's pushing it in the direction it's rotating. This keeps going this way, and it's actually attracted to this pole. And as at this instant in time, as this rotates under its angular momentum, this negative here approaches the positive, and as it wants to, lines up with it and says, I'm happy, I'm going to reach equilibrium. Well, not so fast, because this rotor, this here dynamo, just rotated also, as they are doing at the same time, and now it made a full rotation. This is now where the positive faces, and this is the negative. Guess what? This is negative, this is positive, this is positive. Now what? Now I want to keep rotating. No equilibrium for you, because you're going to go, you want to be repelled from here, attracted to here. Rotation
so it's like
continues.
tricking the magnets in a way,
Yeah.
over and over.
Rotation continues and continues.
I didn't know engines were based on magnets. Like, I didn't
Yeah.
know that. Magnets and electricity. I mean, I thought really that they were based, that's why gas. I didn't know.
Now later, of course, now magnets have to be mined and all that stuff,
Yeah.
and magnets are actually not as strong. Magnets, your magnet is limited to how much flux can go through it, right? How much of those. Now, so what they did later, and this is what Tesla did, he said, this magnet I can increase this voltage, right, and current, but this magnet is not spinning any faster. There's a limit. So that's fine. What we'll do is we'll go like this. So if I do this, if I take and just tap from these wires and run them to the somewhere on the rotor here, so that it is charged now. Make a winding. So this now is a coil, and no magnet, but same exact effect as here. This is an electromagnetic coil. Now it doesn't have a limit. It's only limited to how many times I can wrap around. If I have 50,000 loops here, and I apply X amount of voltage to it, right? Then that magnetic field I have no limit. I can adjust how big that magnetic field can be. Now that is much more powerful because that magnet had a limit. This is only limited by how much wire you put on here. So now we have this is positive right now, right? We're gonna go ahead and let's say this will be charging this pole here, and this will be tapped here and we'll be charging this pole. This is inside the armature, right? This is where the armature comes in here. And this and these are two windings, right? As this changes, this changes, this changes, and the fields interact, constantly changing, 60 times per second.
Wow,
60 times per second.
that's
So,
crazy.
yeah.
Okay.
And so there's that, those interacting magnetic